Now in this video I'm going to introduce another level of complexity which might be a little bit trippy the first time you hear it, but it's fairly sensible and logical and straightforward. So if you have a look here on this example, look at this. This is what you'll find in some maps, and it seems to be saying, because exactly it is saying, that on this map there are three different norths. There's what we call the grid north, the true north, and the magnetic north. So let's just summarise what they are. So the magnetic north is where your compass would point to, because there's like a big magnetic bar in the middle of the earth making magnetic fields, and your compass follows those magnetic fields and will point to where magnetic north is. But where true north really is, the axis that the earth spins around, that's located over here. So magnetic north and true north are close, but they're not exactly the same. So on your map there'll be a line pointing to where true north really is, and a line pointing to where your compass would say north is. And of course in our previous examples we've been talking about the grid lines. So the grid lines are supposed to mimic the lines of longitude, which of course are not parallel, but on a map they are drawn parallel for the purposes of drawing the map. So these lines are considered to be what the map is suggesting north might be, or this is what's called the grid north. Now have a look on this particular example here. This is a really overinflated, overexpanded version of what you'd find on a map. These lines down the side here are the actual meridians, the lines of longitude. So you can have a look up here at this particular diagram. There's the North Pole, the lines of longitude leave the North Pole, and as you can see as they leave they're spreading out away from one another, and then they would recombine down at the South Pole. So these lines here, if I followed them, you would end up at true north. Now you think, well, that's a bit funny, that one, they're spreading out away from each other. Well, because it says here we're in the southern hemisphere. So in the southern hemisphere, here's the South Pole down here. Yes, they spread out, get to their widest at the equator, and then recombine at the North Pole. So these lines are where north really is located. So there's our three norths. These lines here are our grid north, these lines here are our true north, and where your compass points to is your magnetic north. So let's put all of that into a question. So this diagram here, I've reproduced part of it here on this piece of paper. Now, we're going to use this because we're told that there's a person was using their compass back in the year 2013. Now that's important. Told the map they were using had a grid bearing of 207 degrees. So the question says that if the grid bearing was 207 degrees, what would the true bearing be? And what would the magnetic bearing be? The true bearing one, that's very simple and straightforward. We just can use this information here. The angle is given, the grid and the true are separated by 0.1 of a degree. So all we did was take our 207 that our grid bearing is, and then we take the 0.1, which is the difference between the two of them, how far they're separated. We either add or subtract. The easiest way I've learned over time to know whether to add or subtract is like this. We have a grid bearing, so we're here on this particular line. We want to get to the true bearing, which means we're travelling that direction. That's a clockwise direction. If it was the other way around, if I had the true bearing and I wanted to work backwards to the grid bearing, I'd be going in the anti-clockwise direction. The way I've always remembered is, if you're travelling in the anti-clockwise direction, A for anti, then it's going to be A for add. Which of course then means if you're travelling in the clockwise direction, you're going to have to subtract. Go through that again. I've got the grid bearing. I want to get to the true bearing. So I go to my, my diagram up here. I've got my grid. I want to travel to my true. So I'm travelling that direction, which is a clockwise direction. Therefore, I'm subtracting. Subtract them. So the true bearing is going to be 206.9 degrees. Hey, that's very simple and straightforward. Now, the one that's going to cause a little bit of difficulty is the magnetic bearing. Now, according to this information, the magnetic bearing is separated from the grid bearing by 11.3 degrees. That's not a problem in itself. What the problem is, because the magnetic north actually moves around over years. In this particular example, it moves about 0.1 of a degree every 2 years. And so this particular figure, we're told, is correct for 1983. So in 1983, the separation between grid and magnetic was 11.3 degrees, but has been moving 0.1 of a degree every 2 years, and we're told that it's been moving in an easterly direction. So magnetic north has been getting progressively more and more out that way, getting further and further from the grid north. Alright, so let's try and do that. First of all, I'm going to work out what the adjustment is going to be. So the adjustment is currently 11.3 degrees. But it's been moving. How much has it been moving? It's been moving 0.1 of a degree. So I'm going to add on 0.1 of a degree. And I know that I'm adding because it's getting more and more easterly. It's getting further away from the grid. Now it moves 0.1 degree every 2 years. It was correct for 1983. According to the question, we're in 2013. That's 30 years. So that 0.1 is going to be multiplied by 30 divided by 2 because it moves 0.1 degree every 2 years. That's why I'm dividing by 2. So when I plug that into my calculator, so my variation now is going to be 12.8 degrees. So now I can go to the second step, which is what is my magnetic bearing actually going to be? So my magnetic bearing is going to be, according to the question, it's 207 degrees. The adjustment is going to be 12.8 degrees. Now, do I add or subtract? I've got the grid. I want to go to magnetic. So I've got grid. I'm traveling to magnetic. That's a clockwise direction, means I must be subtracting. I subtract those two figures, and that will come to 194.2 degrees. That's the style of question you're going to come across. You need to be able to work out these adjustments, whether you are adding or subtracting, depending which way you need to travel. You need to be able to adjust your magnetic by how much it varies every year or a couple of years. So this contains all the information you need. So you will be looking for this information here, be able to apply it to your questions. So I've just done example number 7 from the textbook. You can work your way through example number 8 and see where it leads you, and then move on to the appropriate exercises.